In this video, we'll explain the run-length encoding (RLE) algorithm, a lossless data compression method that reduces sequences of consecutive repeated values. We'll walk through the idea step by step, how the data is compared, how repetitions are counted, and how the original text is converted into a compact encoded form, while also showing the data size before and after compression. Here we start with the original data, shown as a single continuous string. Each character in this string occupies 1 byte, or 8 bits. Before applying any compression, this is the total size of the data as it is stored in memory. At this stage, the string is represented as an array of characters. Each character is stored in a separate memory location. These memory locations are arranged sequentially, forming a continuous sequence in memory. Every block represents a single character, and each character occupies 1 byte, or 8 bits. Now the algorithm begins the main loop. First, it sets the index I to start from 1, because each step compares the current character with the one just before it. At every iteration, we look at 2 adjacent elements in the data array: data open bracket I minus 1 close bracket and data open bracket I close bracket. These 2 cells are highlighted so we can see exactly which characters are being checked. Next, the algorithm evaluates the condition. Are the 2 characters equal? If they are equal, that means the repetition is continuing, so the counter count increases by 1. You can see the value of count update immediately in the variables panel. After that, the loop moves forward by 1 step. The index I increases, the highlight shifts to the next pair of characters, and the same comparison process repeats. During this phase, the encoded output remains empty because the algorithm only writes to the encoded result when it detects a change. As long as consecutive characters match, we keep counting how many times the current character repeats. This is why the visual tracking is important. It shows how I moves through memory, how count grows during repetition, and how the algorithm builds its state step by step before creating any encoded chunks. At this point, the encoding process is complete. The encoded chunks are combined into one final compressed string. This step only brings the result together into a single sequence without changing the data itself. Below, we compare the size of the data before and after compression. The original string takes 33 bytes, while the compressed version takes only 14 bytes. This means we saved a significant amount of storage space. Finally, the compression ratio shows how much smaller the compressed data is compared to the original, while still preserving all the information.